Okay, so we've talked about sine, cosine, tangent. We've talked about their graphs. And now we need to talk about the inverse. Okay? The inverse trig functions. Okay? Now, another word for the inverse sine is the arc sine. Okay? So just understand, if you see arc sine, that's the same as the inverse sine. Okay? So, it says here the unique angle y in the interval from negative pi over 2 to pi over 2 such that y is the inverse sine of x. Now this is important right here. This is very important. Now we're not going to really graph these, but knowing what the domain and range are very important. If you remember back to 4,4 for sine, the domain was all real numbers for sine, and the range was from -1 to 1. Notice now the domain is from -1 to 1. Very important that you know that. Very important that you understand that fact because, and I don't really care about the graph. First example, find the exact value of each expression without a calculator. So we can't use a calculator for this. Okay? So what we want to do is, we want to find the angle whose sine is 1/2. So the inverse is going to tell you what the angle is. Okay? This whole chapter, we've been talking about, hey, find the sine of this angle, cosine of this angle, tangent of this angle. Now it's, all right, here's the ratio, tell me what the angle is. So what we want to do here, okay, is we're going to make our reference triangle. Now sine's positive in the first quadrant, so we're going to go there. So here's my theta, okay? Now, opposite over hypotenuse, right? So that's 1 over 2. Now, I'm thinking specifically of our 4590, oh, don't put it out there, our 4590, okay, 1, 1, radical 2, and our 30, 60, 90 triangles. Because again, all right, they are not going to tell you to find it without a calculator if it's not 30, 60, or 45. Okay? So which one of those angles has a sine of 1/2? 30 degrees does. Opposite over hypotenuse. So the answer, pi over 6. Or if you wrote 30 degrees, that's not wrong. They don't specify. Part B. Okay? Now, what angle has an inverse sine of negative radical 3 over 2? Now, we have to remember that all of our angles are going to be between negative pi over 2 and pi over 2. Okay? That's what this means. So our answers here, okay, our answers for these first three, okay, are going to be between negative pi over 2 and pi over 2. Now, what quadrant is the sine negative? Well, the sine is negative in the fourth quadrant. Okay, so here's our right angle, here's our theta. So opposite radical 3 over hypotenuse 2. Well, opposite hypotenuse, that means we have negative 60, which is negative pi over 3, which is also 60 degrees. Okay. Now, for part C, okay, the inverse sine of pi over 2. Now, first of all, we've never found the sine of an angle and said, oh, well, the sine of however many degrees is pi over 2. We've never done that. We've never said that. Okay? This does not exist because the domain, our domain, is from -1 to 1, right? That's what we talked about here. And pi over 2 is greater than 1. think about it. 3.14 divided by 2. That's like, over 1.5. Okay? Well, if this number doesn't fit the domain, well, then you can't do it. All right? Our numbers in the parentheses have to be between -1 and 1. All right, D and E, we don't need reference triangles because I'm taking the inverse sine of a sine. Now, this is sort of like when you square a square root, right? The power and the root go away, and the number is all that's left. Well, that's what happens here. These essentially cancel out, so your answer is pi over 9. Same thing here. So your answer is 5 pi over 6. Okay, so those are easy ones. Anytime you're doing an inverse sine of a sine, an inverse cosine of a cosine, an inverse tangent of a tangent, those just cancel out, and whatever's in the parentheses is all that's left. Okay, so now obviously this is just a calculator exercise, but notice in the directions they say use a calculator in radian mode. Okay, radian mode. So make sure on your calculator, mode is in radians. So I punch in inverse sine of -0.81, and it gets me -0.944. Okay, I would round to the nearest thousandth. Okay, part B. Now, remember we talked about like the sine and the inverse sine cancel out? Not necessarily here. Okay, not when you're in radians, not when you're it says use a calculator. So physically put that in your calculator. You're going to get -1.539. Okay, so that's just a calculator exercise. You guys can do that. Inverse cosine. Okay, inverse cosine, domain -1 to 1, range 0 to pi. You might see it say arc cosine. Arc cosine is the same as inverse. Same thing for tangent. Okay. Now it says evaluate these inverse trig functions without a calculator. Now, okay, again, oh, that's it. I was going to draw a right triangle, folks, and that was fixing to be terrible. Although to be fair, this one isn't much better. 45, 45, 90. So 1, 1, radical 2. 30, 60, 90, 1, radical 3, 2. Okay. Which angle, okay, has a cosine of negative radical 2 over 2? Now, that is in quadrant 2. Okay. So, what's the reference angle? That's really what we're finding. So radical 2 over 2, so adjacent over hypotenuse is 1 over radical 2, which, by the way, turns into radical 2. Whoops. Can't go to the next slide yet. No, don't go to the next slide. No. Don't. 1 over radical 2 goes to radical 2 over 2. All right? Because the cosine's negative, we're in the second quadrant. Okay? So that's 45 degrees. So the reference angle would be 45 degrees. But that's not what they're looking for. Okay? They want to know what this angle is. So for part A, we would just do 180 minus 45. So it's 135 degrees, which could also be written as 3 pi over 4. By the way, if you look at your unit circle, you could do a lot of these too. You don't need the triangle. Well, I mean, you can use the triangles, but you could also use your unit circle to figure this out as well. Part B, inverse tangent of radical 3. Okay? Now remember, opposite over hypotenuse is tangent. Opposite over, oh, I'm sorry. Sorry. You're all screaming right now. It's opposite over adjacent, not opposite over hypotenuse. Okay. It's opposite over adjacent. I got it. Opposite over adjacent. Radical 3 over 1, 60 degrees. Or as it's better known in radians, pi over 3. Okay. Part C, inverse cosine of the cosine of negative 1.1. Now again, those cancel, but here's the issue. Okay, that negative 1.1 has to be positive. Okay, it has to be between 0 and pi. Because if you come back here, the range is between 0 and pi. Okay, so negative 1.1 has to become positive 1.1. Okay, so really just finding the inverse, this is more practice with using your special right triangles and using the unit circle. Okay, you could use either of those to help you out there. And then everything else is just a calculator exercise, which we all know you're very good at.